Hello, everybody, and welcome to the class. This is going to be the introduction for Chapter 1 of Python Machine Learning. In this lesson, we will introduce the foundation of machine learning and the Python working environment. This chapter is important because it gives us the vocabulary, concept, and mindset we will use through the rest of the course. Before we start building machine learning models, we need to understand the big picture. What is machine learning? What does that matter? What is Python commonly used? And what does it mean to train, test, and evaluate a model? Chapter 1 gives you the foundation for all those ideas. The goal is not to memorize every term immediately. The goal is to understand how machine learning works at a high level of how Python helps us apply those ideas in practice. Since this is a summer course, the pace will be faster than a regular semester. That means the students need to stay organized, practice regularly, and begin assignments early. Machine learning is a topic that becomes clearer with repetition. Watching the lesson is helpful, but the real learning happens when you read, write code, make mistakes, troubleshoot, and try again. Machine learning is a field of artificial intelligence that allows computers to learn patterns from data. Instead of giving the computer every rule manually, we give it examples. The algorithm studies those examples, identifies patterns, and creates a model that can be used to make predictions, classifications, or decisions. At a simple level, machine learning is about using data to help a computer make informed guesses about new situations. In traditional programming, a human writes the rules. The computer receives input, follows the rules, and produces an output. For example, if we write a program to calculate sales tax, we already know the rule. Multiply the price by the tax rate. The computer simply follows that instruction. Machine learning works differently. In machine learning, we provide data that an example of correct outcomes. The algorithm studies those examples and learns patterns. Instead of the human writing every rule, the model learns from the data. That difference is one of the most important ideas in Chapter 1. A common example of machine learning is spam detection. Instead of manually writing every possible rule for what makes an email spam, we can train a model using examples. Some emails are labeled as spam, and others are labeled as not spam. The model learns patterns from those examples. It might notice certain words, links, formatting, sender, behavior, or other signals. Later, when a new email arrives, the model can predict whether this email is likely to be a spam or not a spam. This is an example of classification because the model is choosing between categories. Machine learning is important because organizations collect large amounts of data every day. That data may come from websites, apps, transactions, sensors, student systems, business systems, support tickets, and many other sources. The value of data comes from using it to understand patterns and support better decisions. Machine learning helps organizations predict outcomes, identify trends, automate repetitive tasks, and detect unusual activity. This is why machine learning is used in business, education, healthcare, cybersecurity, automation, and technology support. Let's look at some real world examples. Recommendation system suggests products, movies, videos, or music based on a pattern in user behavior. Fraud detection system look for unusual transactions that might indicate suspicious activity. Image recognition systems can identify objects, faces, handwriting, or medical image. In education, machine learning can help identify student success trends or recommend support resources. In technology support, machine learning can help classify help desk tickets and route them to the correct team. These examples all have something in common. They use data to identify patterns and make predictions or classifications. The first vocabulary term is data. Data is the information that can be collected, stored, and analyzed. Data can include numbers, text, dates, categories, image, audio, or other type of information. A dataset is a collection of related data organized for analysis. A dataset might look like a spreadsheet where rows represent individual records and columns represent different pieces of information. In machine learning, the dataset is the starting point. Without data, there's nothing for the model to learn from. Two important terms in machine learning are features and labels. Features are the input variables used by the model. For example, in a student dataset, features might include attendance, number of assignments submitted, quiz average, or login activity. The label is the answer or outcomes the model is trying to learn. In the same student dataset, the label might be wherever the student passes or did not pass. The model uses the feature to learn patterns that help it predict the label. Another important distinction is the difference between an algorithm and a model. An algorithm is the method used to learn from data. It's a procedure or technique that looks for patterns. A model is the result of learning process. After the algorithm has studied the training data, it produces a model that can be used to make predictions. Training is the process of teaching the model using examples. During training, the algorithm looks at the relationship between the features and the label and tries to learn patterns that can be applied to new data. After a model is trained, we need to test it. Testing means checking the model with data it has not already learned from. This helps us understand whether the model can work well on new examples, not just the example it already saw during training. The prediction is the output produced by the model. For example, the model might predict a price, a category, a risk level, or a final result. Evaluation means measuring how well the model performs. We don't not want to trust a model just because it produces an answer. We need to measure whether that answer is useful and accurate. Two common types of supervised machine learning problems are classification and regression. Classification means predict a category. For example, spam or not spam, pass or not pass, approve or deny, high risk or low risk. Regression means predicting a number, for example, a house price, a test score, a temperature, a sales amount, or a demand level. This distinction matters because the type of problem affects the type of model and evaluation method we use. Machine learning is commonly divided into three major types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning uses labeled examples. The model learns from data where the correct answer is already known. Unsupervised learning uses data without known labels. The goal is to discover patterns, groups, or relationships. Reinforcement learning involves an agent that learns by interacting with an environment and receiving rewards or penalties. In this course, we will focus mostly on supervised learning, but it's helpful to understand where the different categories fit. Supervised learning is one of the most common types of machine learning. In supervised learning, the dataset includes both input features and known labels. The model learns from those examples and then uses what it learned to make prediction of new data. For example, if we have a student records that includes attendance, assignments, quiz average, and final course result, the model can learn patterns from past students. Later, it might help predict whether a future student may need support. Supervised learning includes both classification and regression. Unsupervised learning is different because the data doesn't include known labels. Instead of learning from correct answer, the algorithm looks for patterns in the data. One common unsupervised learning task is clustering, where similar records are grouped together. For example, a business might group customers based on purchase behavior. A college might group courses, activity patterns to better understand how students interact with other materials. The goal is not to predict a known answer. The goal is to discover a structure in the data. Machine learning follows a structured workflow. First, define the problem. What are we trying to predict, classify, or understand? Second, collect the data. Data might come from files, databases, application logs, or public datasets. Third, prepare the data. Real-world data is often messy, so it must be cleaned and organized. Fourth, explore the data. We use summaries and visualizations to understand the patterns and possible issues. Then we choose a model, train the model, test the model, evaluate the results, and use the model responsibly. This workflow is important because machine learning is not just running an algorithm, it's a process. Data preparation is one of the most important parts of machine learning. Real-world data is often messy. It might contain missing values, duplicate records, inconsistent formatting, incorrect entries, or columns that are not useful. The data is poor. The model results might also be poor. A machine learning model can only learn from the data it receives. That is why cleaning the preparations are essential. Good machine learning starts with a good data practices. Exploratory data analysis, often called EDA, is the process of examining data before building a model. During EDA, we use summaries, tables, and visualizations to understand what the data looks like. We might look for patterns, relationships, outliers, missing values, or unusual behavior. For example, we might create or chart to see whenever attendance is related to final grades, or we might calculate average to determine how different groups compare. EDA helps us understand the datasets before we try to make predictions with it. Python is one of the most popular programming languages for machine learning. One reason is the readability. Python code is usually easier to read and write than many other programming languages, which make it a strong choice for students and professionals. Another reason is the large ecosystem of libraries. Python has a powerful tool for working with numbers, tables, charts, and machine learning models. Python also has a large community, which means there are many examples, tutorials, documented pages, and support resources available. In this course, Python is the main tool we will use to work with data and build machine learning solutions. Throughout the course, students will use several important Python tools. NumPy is used for numerical computing and working with arrays. Pandas is used for working with tabular data, similar to spreadsheets or databases tables. Visualization libraries are used to create charts and graphs, which helps to use understand data. Scikit-learn is used to build and evaluate machine learning models. Chapter 1 introduces the foundation. Later chapters and modules will have us more hands-on practice with those tools. A Python working environment is where we write, run, test, and explain Python code. In machine learning, many people use notebooks, such as Jupyter Notebook or Google Colab. A notebook lets you combine code, output charts, notes, and explanations in one place. This is useful because machine learning is often explanatory. We might load data, inspect it, clean it, create charts, and train a model, and explain the results all in the same notebook. A typical notebook workflow might begin by importing libraries. Next, we load a dataset. Then we inspect the first few rows to understand the structure of the data. After that, we clean and prepare the data, create visualizations, train a model, and evaluate the results. For example, a simple notebook might import Pandas, read a CSV file, and display the first few rows of the dataset. This is step-by-step workflow helps us understand what is happening instead of treating machine learning like a black box. Let's use a simple student dataset as an example. Imagine the dataset includes attendance, assignments submitted, quiz average, login activity, and final result. Attendance, assignments submitted, quiz average, and login activity are features. They are the input variables. The final result is the label. It is the outcome we want to model to learn. A model would study past student records and identifies patterns that might help predict whether a future student is likely to pass or might need support. This example shows how machine learning can connect data to real-world decision support. Machine learning must be used responsibly. Before trusting a model, we should ask important questions. Is the data accurate? Is the data complete? Could the data be biased? Can the result be explained? How will the prediction be used? A model should not be trained as automatically correct just because it produces an answer. Responsible machine learning requires both technical skills and ethical judgment. Bias can happen when the training data is incomplete, unbalanced, or based on unfair historical patterns. For example, if a student success model is trained on incomplete data, it might produce predictions that not fairly represent all students. That is why predictions should be used carefully. A model can support decision making, but it should not replace human judgment blindly. In education, the goal of prediction should be to provide support, not to label students unfairly. Chapter 1 prepares us for the rest of the course. Next, we will work more directly with Python tools. We will use NumPy for numerical data, Panda for tables and datasets, visualization tool for charts, and scikit-learn for machine learning models. Later, we will study linear regression, logistic regression, and k-nearest neighbors. All those topics build on foundation from Chapter 1: data, features, labels, model, training, testing, evaluation, and responsible use. To succeed in this course, practice Python regularly. Don't wait until the last day to begin assignment. Coding takes time and troubleshooting is part of the learning process. Read error messages carefully. They often clues about what went wrong. Ask questions when you get stuck. Review examples. Focus on understanding the workflow, not just copying code. Also, keep up with the certificate work each week. In a summer course, failing behind can become difficult very quickly. Let's recap the main ideas from Chapter 1. Machine learning allows computers to learn patterns from data. Data contains features and labels. Features are the inputs, and labels are the outcomes we want to predict. Models are trained, tested, and evaluated before their use. Python is the main tool we will use for data analysis and machine learning. And finally, machine learning must be used responsibly, with attention to bias, fairness, and transparency. Chapter 1 is the starting point for the rest of the course. The goal is to understand the basic concepts before moving into hands-on Python and machine learning work. As you review this chapter, focus on the vocabulary, the workflow, and the reason machine learning is useful. In the next lesson, we will begin using Python more directly to work with data and prepare for building machine learning models.